We need to graph linear functions. It is the foundation of graphing. So let's learn it in the most efficient and accurate way. And at the very end of the video, I'm going to include many practice problems that you can use to see if you really understood the topic. Let's start by defining what a linear function is. For now, we'll use a simple definition. A linear function is a function whose graph is a straight line. In fact, that's exactly what the word linear suggests. It comes from the word line. So whenever you graph a linear function, you should expect to see a line. If you've taken a math class before, you may know this isn't the full definition. We will build a more precise definition as we go and see why it works. Every function has a general equation. For linear functions, that equation is y equals mx plus b. The input of this function is x, which represents the x coordination of a point. The output is y, which represents the y coordination of that same point. So, whenever a point is on the line, its coordinates must satisfy the equation. Now, let's look at the two most important numbers in this equation, m and b. First, we have m. The number m is called the slope, and it determines how steep the line is. To understand slope, imagine moving from one point on the line to another. As you move, two things can happen. You move up or down, or you move left or right. The amount you move up or down is called the rise. The amount you move left or right is called the run. The slope is simply the ratio between these two values. Slope is rise over run. This makes sense because the steeper line rises more for the same horizontal movement. As you change the value of m on the graph, watch what happens to the line. When m gets larger, the line rises more for the same horizontal movement, so the line becomes steeper. When m gets smaller, the line becomes less steep. This is why the slope tells us exactly how steep a line is. When we calculate slope using coordinates, we use this formula. This formula is just another way of saying rise over run. The numerator, y2 minus y1, measures the vertical change, or rise. The denominator, x2 minus x1, measures the horizontal change, or run. If the slope is positive, the line rises as you move from left to right. If the slope is negative, the line falls as you move from left to right. If the slope is 0, the line is perfectly horizontal. Now, let's look at the second number in the equation, b. The number b is called the y-intercept. We'll soon see exactly why it is called the y-intercept. But for now, just remember that it tells us where the line crosses the y-axis. When we graph a linear function, the line will intersect the y-axis at the value of b. Now that we understand the equation of a line, let's learn how to graph one. A useful fact from geometry is that one straight line can pass through any two distinct points. This means that if we can find 2 points that lie on a line, we can graph the entire line by plotting those 2 points and connecting them. So let's find 2 points. One way to find points is by creating a table of values. Choose any x value you like. For your own sake though, it's usually best to choose easy numbers such as 0, 1, 2, or -1. Your calculator will appreciate the break. Then substitute that x value into the equation and solve for y. The x value and the y value together form a point on that line. Repeat the process with another x value to find a second point. Once you have 2 points, you can plot them and draw a line through them. However, if you want your graph to be accurate, it is also important to know exactly where the line crosses the axis. These special points are called intercepts. An intercept is a point where the line crosses one of the axes. Let's start with the x-intercept. The x-intercept is where the line crosses the x-axis. Every point on the x-axis has a y coordinate of 0. So to find the x-intercept, we set y equal to 0 and solve for x. Once you find x, the intercept will be x and 0. Now let's find the y-intercept. The y-intercept is where the line crosses the vertical axis. Every point on the vertical axis has an x-coordinate of 0. So to find the y-intercept, we set x equal to 0 and solve for y. Once you find y, the intercept will be 0 and y. At this point, we have 2 random points on our table and 2 intercepts from the axis. You might be wondering, if 2 points are enough to graph a line, why did we go through all that work to find 4 points? That's a great question. The truth is that we actually didn't need to find 2 random points at first. The table method is a useful way to generate points on a line and helps us understand how graphing works. However, the intercepts are also points on the line. Since finding the x-intercept and y-intercept already gives us 2 points, we could have simply found those 2 intercepts from the beginning, plotted them, and drawn the line through them. So while the table method is a good introduction to graphing, in practice, finding the intercept is usually the most efficient way to graph a linear function. Now that we have our 2 intercepts, we get to the easiest part of graphing, actually drawing the graph. Start by plotting 2 intercepts you found. Then draw a straight line through them and extend it in both directions. Then draw a straight line through them and extend it in both directions to infinity. Not literally to infinity, of course. Your paper probably isn't that big, but far enough to clearly show the direction of the line. And just like that, you have graphed a linear function. Before moving on, it is always a good idea to check your graph. One quick check is to look at the slope. If the slope is positive, the line should rise as you move from left to right. If the slope is negative, the line should fall as you move from left to right. If the slope is 0, the line should be perfectly horizontal. If your graph doesn't match the sign of the slope, there is probably a mistake somewhere. You can also perform a more thorough check. Choose any 2 points on your graph and calculate the slope between them. If you get the same slope as the one in the original equation, that's a good sign that your graph is correct. You can even go one step further and use the slope and y-intercept from your graph to reconstruct the equation of the line. If the equation you get matches the original equation, then you can be confident that your graph is correct. And that's it. You now know how to take a linear equation, find its intercept, graph those points, and draw the line that represents the function. In this video, we focused on how to graph linear functions, but this is only one part of a much bigger topic. There is still a lot more to understand about linear functions, such as how they behave in real-world situations, how to interpret them in word problems, and how to work with different forms of equations. If you want to learn more about linear functions or any other math topic, let me know in the comments. I'll make more videos based on what you need. And now, here are the practice problems I promised. Try them on your own before looking up the answers. You'll learn much more that way.